Hello, and welcome to our online tech talk. In this session, we'll be talking about what is SQL Server end of support and what are your options in the cloud to help address it. My name is Andy Hopper, and I'm the worldwide tech leader for Microsoft Workloads here at AWS. And I'm joined by my colleague Yogi Bharat. Yogi?
Hi everyone, my name is Yogi Barot and I'm part of Microsoft Specialist Principal Solutions Architect at AWS. Part of my role, I help customer migrate their Microsoft workload to AWS cloud. Today, we will be talking about what is SQL Server end of support and what it means to me and why customer migrate SQL Server workload to AWS and what are the options for deploying SQL Server on AWS, like rehosting, replatforming, and refactoring. And we'll also watch a demo of doing a SQL Server 2012 upgrade using AWS System Manager Automation Runbook. And at the end, we'll talk about how do we get started with all this. So, what is SQL Server end of support? Each SQL Server version has 10 years of support. So first 5 years is mainstream support and the next 5 years is extended security support. So during the mainstream support, we get updates to the new features and security updates. And during the extended support, uh, it's only included the security updates only. On July 12, Microsoft SQL Server 2012 will be reaching its end of support, which means companies will no longer have access to security updates or patches. This could leave companies vulnerable to security risk. So, the application running with unsupported SQL Server database may cause compliance issue and security risk. Risk to SQL Server database is heavy because attackers know how to exploit unpatched database and they still have access to default accounts and configuration parameters. So because of this, unfortunately, organization has to struggle to stay on top of maintaining database configuration. You might think why SQL 2012 is matter to me because it's an older SQL Server version. Well, the latest security patch was released on January 2022 of this year. So that means if your database is not getting security patched, you have a bigger risk. I'm going to pass it to Andy to talk about why to migrate SQL Server workload to AWS.
All right, thanks, Yogi. So before we discuss how you can address end of support, we should first discuss why you should consider migrating SQL workloads to AWS in the first place. These days, the benefits of migrating to the cloud, such as agility, elasticity, speed of innovation, cost reduction, and many more, are practically common knowledge. On top of that, AWS offers best in class performance for SQL Server workloads, and we'll talk more on that in just a bit. We also offer a broad range of virtual machine instances and a comprehensive set of tools and programs to support your cloud migration. When deploying on AWS, customers benefit from a remarkable pace of innovation. And what this means for you is that you can be assured that your workloads are running on the most advanced and modern platform. AWS has been helping customers run SQL workloads for almost 14 years now. And because of that experience, we have helped our customers achieve a lower total cost of ownership. Benchmarks run by an independent third party show that AWS delivers a price performance ratio for SQL Server workloads that is up to 68% better than the next largest cloud provider. AWS also offers higher raw performance and reliability than that next largest cloud provider. In fact, AWS delivers 1.79 times higher transactional throughput with 1.9 times lower average transactional latency. There are also flexible licensing options for when you have existing SQL licenses, reduced operational complexity, and we have a broad range of security related services to manage aspects such as data and traffic encryption, as well as security auditing and compliance attestations such as PCI, HIPAA, and FedRAMP for security critical workloads. So let's take a closer look at the performance of SQL on AWS. The results you see here are from a third party named Principal Technologies, who ran a benchmark study comparing SQL workloads on comparable instances between AWS and the next largest cloud provider. This study found that overall, SQL workloads run faster on AWS. And again, this is at a price point that was 68% lower. These results illustrate AWS's deep investment in optimizing our services and infrastructure to help our customers that are running Windows and SQL Server workloads achieve the best results at the lowest cost. Now, I mentioned licensing before. Here at AWS, you have many options for managing your SQL licenses. First, there's the license included model, which is also referred to as pay as you go. With this model, AWS manages all the licensing of SQL for you. You simply launch an instance with SQL pre-installed and you deploy your database to it. This is a great option for either short-lived database workloads or cases where you simply just don't want to have to manage the licenses yourself. However, if you do have SQL Server licenses that you've already paid for, we have several other options. For customers with active software assurance license mobility, they can apply their licenses to run SQL on standard EC2 instances using our default tenancy hosting model. However, for customers who are not covered under SA license mobility anymore, they can still bring those licenses and apply them to either cores or vCPUs under our dedicated host model. And regardless of which approach you choose, we also offer a service called License Manager, which helps to simplify the bookkeeping that comes with tracking where you apply those licenses. In addition, we also offer something called an optimization and licensing assessment. This process analyzes your utilization of Windows and SQL Server licenses in your existing environment, and in many cases can help customers reduce their overall license footprint and therefore their cost. Now, when you're ready to migrate your database servers to AWS, we offer a bunch of tools and hosting options to help you. Whether it's making a complete copy of the database server and running it on our Elastic Compute Cloud or EC2 infrastructure, or simply moving the data itself over, we have a set of tools to ease that migration process. As far as the hosting environment is concerned, you can always continue to run SQL Server yourself on EC2, but be aware that we also have a fully managed database hosting service called Relational Database Service, where AWS will own all of the maintenance of the host the database runs on, which allows your DBAs to focus on what really matters, namely innovation and performance tuning of your applications. All right, I'm going to hand it back over to Yogi.
Okay, so let's talk about SQL Server deployment options on AWS. So when you consider your options for migrating your database workload to AWS, you have three sets of concern, namely speed, risk, and innovation. Obviously, you want to have a fastest performing database in the cloud. At the same time, you want to take minimum risk and take advantage of cloud innovation as well. So the fastest and the lowest risk approach is, of course, simply rehosting to Amazon EC2. With rehosting, you are lifting and shifting your database server into cloud. So, however, you are still be left with all the overhead that comes with operating that server. And while you also realize some of the benefit of operating in the cloud with this approach. The second option is to replatforming to RDS for SQL Server. For many customers, the great step is to use our relational database service to host your database. This is still a fairly low risk approach because it is still using a SQL Server engine, and AWS offers many services to accelerate your migration to RDS SQL Server. RDS is a fully managed database service, so you begin to free up DBA's time to innovate rather than engaging and taking care of database server, like patching of SQL Server, patching of operating system, maintaining the backups, and all the stuff. And finally, for many customers, a move to a purpose-built database enable them to get the most benefit of the operating in the cloud. So rather than shoehorning a workload that really should not be run for a relational database engine like SQL Server, now you are able to select from a long list of database engine that AWS offers. such as Amazon Aurora for PostgreSQL, Amazon Aurora for MySQL, DynamoDB for NoSQL, and so on. So making some sort of changes come with some degree of risk. So you need to determine what path you want to go, whether you want to lift and shift, you want to go with fully managed service, or you want to go with a purpose built database. Running SQL Server on AWS virtual machine is like running SQL Server on premise, with an exception that now you have a flexibility to use multiple AWS instance type, as well as we have an access to whole set of management and monitoring tools provided by AWS. We have a plenty of instance type which offers a great CPU, memory, and IOPS that you can select for hosting your SQL Server workload, including the multiple storage options. When you rehost your SQL Server to AWS, it's an easy and fast option with no code change. You will have full access to SQL Server database as well as full access to RDP to EC2 instance. And at the same time, you can use your existing licensing investment. And now you have an opportunity to rehost to SQL Server on EC2 Linux and take advantage of saving Windows Server licensing cost. So now let's talk about RDS. RDS for SQL Server, AWS takes care of all the heavy lifting and leaving you to focus on business value tasks like performance tuning and optimization. It also offers a push button scaling for compute, memory, and storage as your workload changes over time. The main benefit about RDS SQL Server, which I like, is multi-AZ feature. Just with a single click, you can get multi-AZ setup. That means you will have a high availability setup for you. And AWS takes care of setting up, monitoring, and maintaining that HA replica for you. Coming from a DBA background, I know how difficult it is to maintain and set up your high availability database. At the same time, making sure your backups are automated and your disk does not run out of space. So with RDS SQL Server, customers should not worry about any of these database maintenance and administration tasks, and they can focus on innovation. And lastly, for the customer who are unable to move to the fully managed service due to the customization that they require for specific application like Microsoft SharePoint, we offer Amazon RDS Custom for SQL Server. With RDS Custom, it's our complementary database service that provides a managed database service with access to underlying operating system and in the environment. So now you have a flexibility and control that you get from self-managed EC2. At the same time, you can leverage the automations from managed RDS.
Okay, the last option is refactoring your applications to use purpose built databases. Refactoring your databases to cloud native solutions frees you from the lock in of old guard, monolithic, proprietary, and expensive vendor offerings, which often come with punitive licensing terms. Refactoring is also the most rewarding method for long term business outcomes as it truly accelerates your pace of cloud innovation. And this continuously reduces cost while increasing performance, resilience, and responsiveness. Now, we realize that refactoring can come with a degree of risk. And to help with that, we've created a technology called Babelfish. With Babelfish, you can start the process of moving your applications to the open source PostgreSQL engine, but without having to rewrite all of your data access code. Babelfish provides a translation layer that allows your application to continue to use SQL Server's native TDS protocol, but it translates your application's SQL queries and statements into calls that are compatible with the underlying Postgres engine. Okay, back to Yogi to do a demo for how you can use Systems Manager to do an in-place upgrade of your SQL Server databases.
Now let's do a demo of SQL Server 2012 on EC2, and we will be upgrading that using System Manager Automation Runbook. So what is System Manager? It's an powerful unified interface that provides an ability to centrally manage your AWS resources. So it uses an AWS SSM agent and System Manager documents. So AWS SSM agent is a software that can be installed on your EC2 instance, and it processes the request from the system manager service and then configure machine accordingly, right? So with this automation document, it will create an AMI from your SQL Server 2012 running instance and then perform an in-place upgrade of your SQL 2012 to SQL 2016 or any supported higher version. And the final result is an upgraded instance AMI. So let's check how it works. So as you can see here, this is the SQL Server 2012 instance. We will be using that instance to do an upgrade. Now let's just check a couple of details for this instance. This instance is using a SQL Server 2012 AMI, as you can see here. So what I'll be requiring is to get the subnet ID for this instance. So I'm going to copy that subnet ID. And at the same time, I will also require the IAM role. So I will be copying that IAM role as well, which is in here. Okay, so now these both things are copied. What we'll do is we'll go to the system manager. So let's just type system manager over here and then open that in another tab. So with system manager, what we have different tools available within system manager. We will be looking at automation today. So let's click on automation and then click on execute automation here. As I said, we have a predefined 135 predefined system manager document that we can use it here for automation. So let's look at the SQL Server specific document today. We'll be using this AWS EC2 clone instance and upgrade SQL Server document today in the demo. So let's just click on the document here and click on execute automation. We will need to specify the input parameters. There are a couple of inputs that we need to specify for this automation document. One of them is obviously the instance that you want to upgrade. You can select the instance here. And we need to put an subnet ID that we have copied earlier. So let's put the subnet ID over here. Actually, subnet ID, this is the EC2. I am instance profile here, and then let's just copy the subnet ID here as well. So this is the subnet ID. And another input here is a target version. So we can select the which will be our target SQL Server version. So right now you see here 2014, 2016. I'm going to select 2017 for the demo. And that's it. You don't need to specify any other options over here, just with simple couple of parameters, and we can click on execute the automation. So what this is going to do in the background is basically take your SQL 2012. It will do an in-place upgrade of your SQL 2012 to an SQL 2016, and the final result will be an upgraded instance AMI. So that means just like when you go to your iPhone upgrade, right? So and when you get the new iPhone from, for example, upgrade from iPhone 7 to iPhone 13, you have a new hardware, and with the new hardware, everything, all the data, all the applications, whatever you had it on your previous phone stays as it is, and basically you will get it on the new phone. Same thing, something like that works here in the backend. Everything for your SQL Server, which includes your SQL Server instances, all the databases, master database object, everything stays intact, and you will just have an AMI ready with the SQL Server upgraded version, and you can just launch instance using that. So this is going to execute. As you can see, it started executing the different steps already. It's at step 12 right now. It's going to execute around 53 steps. While it's executing, let me just show you how does the result look like. So we can check here automation. Actually, go back to the executions, and we can see the last successful execution. For example, let's check the result, and I will show you how does it the output looks like. So basically, you can see here this executed successfully up to step 53. It does an upgrade, and result is success over here. The output here is an SQL Server upgraded AMI. So this is an output EC2 SQL Server upgraded AMI, right? So this AMI is available in the EC2 console. So let's just go and validate that. So here is an EC2 console, and I'm going to just go check the AMIs here. And as you can see, this is an AMI, which was a result of the upgrade that I did last time. So this AMI is Windows with SQL Enterprise. And now let's just connect. What we can do is basically I can just launch an instance from the AMI just with a simple click. When I launch the instance, I can specify the instance type and all of the details and then launch the instance, right? So once I launch the instance, everything on my SQL 2012 machine, which was previously upgrade the older version, now you can see that on the newer version. So I have already created the SQL 2017 instance. Let's just check which one is this is upgraded using automation document. So let's check here. We'll be using SQL Server Management Studio. And what I want to show here, as you can see here, this is a SQL 2012. Because this has been upgraded from SQL 2012, you see that when you start for the first time. And I'm going to connect to the local host over here. And let's just see the database and the version. So you can see this is an AdventureWork 2012 database. So this is a 2012 instance that which I had earlier. And then you can check the version of SQL Server, which is right now. Let's just see the version, which is SQL 2017, right? So as you can see, we have successfully upgraded the SQL Server 2012 to a higher version just with few simple clicks, and you have your SQL upgraded already.
Okay, so how can you get started? AWS offers a number of programs to help you accelerate your move to the cloud. This slide is not a comprehensive list, but it does show you some of the more popular options. First, we offer the Optimization and License Assessment program I referred to earlier. This helps you understand the shape of the infrastructure you should plan to run on AWS, as well as help you right size that infrastructure to lower your operational costs. Next, we offer the Migration Acceleration Program, which provides a variety of resources to help you plan and execute that migration. Finally, once you're ready to start moving to open source and cloud native database engines, we offer something called the Database Freedom Program, which provides guidance, assistance, and even financial incentives to move to purpose built database engines. There are three phases in our approach to complete large scale migrations, after which you start operating and optimizing in the cloud. There's an assessment phase where we build a business case and perform a cloud readiness assessment. There's a mobilization phase where we propose an AWS architecture, create a migration plan, and mobilize businesses to migrate at scale. And finally, there's the migration and modernization phase where we move workloads into AWS and a cloud operating model is put in place once you're in AWS to run and optimize for further business benefit. Now, not all customers have the bandwidth to perform all of those steps themselves. And to help with that, we have a deep roster of Amazon Partner Network members who can help you. This list you see here is not a comprehensive list, but it does help you to illustrate just how many partners we have standing by to help you. Okay, this brings us to the end of our talk, and what we have here are a few resources that you may find helpful as you consider your migration to the cloud. And of course, please feel free to reach out to your account team if you'd like to speak with folks like me and Yogi to help you plan your journey. Thank you so much for watching this online tech talk, and we can't wait to see what you build on AWS.
Thank you.